Suppose there is a 1 hour time is there for solving the issue. Minimum 40 to 50 minutes you have to spend on characteristics of the actual system, right? So after that, see, based on the characteristics, as an electrical scholar, your job is you need to identify the needs. Once you know the how system is suffering with particular parameter, if you know, it is not a big deal to control. But see, issue is always we are focusing on control. We are missing the things. If you want control something, what it required basically, in today's session we'll try to focus. Right? If you want to solve the problem, you have to define the problem clearly. You have to spend minimum 40 to 45 minutes to define the problem. That's why what we are doing, we are going through literature survey. Many of the scholars, they are doing PhD, right? But students are spending less time on the review. Dynamically, we need to, day to day, we need to update with, review the topic. Any concept is there, any updation is there, you need to concentrate on, say, problem definition clearly. Once you know problem definition clearly, it is not a big deal to find the solution, right? But thing is, we are doing reverse. We are spending less time on the review. We are focusing more on getting new things, right? How to do modification. This is the lagging, right? So in today's session, I will try to provide the philosophy behind why modeling is required, right? If you know this philosophy, right, as electrical scholar, burden on the scholar will come down. Many of the engineers, particularly electrical engineering scholars, they are suffering to understand the concept. This is the major issue, to understand the actual system behavior. Once you know, see why they are not understanding. Even see, textbooks are there, resources are there, papers are also available. Why people are struggling? Reason is they are going through the theory. You got my point? They are taking papers or textbooks and they are going through the theory. They are not depending on the mathematics. The beauty of electrical engineering is for each and every concept we are having mathematical support. If it depends on the mathematics, right, it is not a big deal to understand the behavior of the system. Right? That is the logic behind the modeling. First, we'll try to focus on modeling. What is the necessity of modeling? See, if you want to develop something, if you want to develop, modeling is nothing but mathematical representation of actual system. Right? See, once you know the mathematical model of the actual system, we can easily extract the characteristics. Once you know the characteristics, what is the next step? We can easily develop the controller. That is what we discussed morning, right? See, particularly our system is what is the nature of our system? Permanent magnet synchronous machine. It is a complex system. It is a AC system, right? Without taking transformation techniques, we cannot develop electrical equivalent model, right? So in next session, in today's session, I will try to explain key points for developing the mathematical model. What is the necessity of transformation technique? What is the significance of control system, right? Control system, it is not a separate subject. It is a part of the system. If you know the characteristics of the actual system, we can easily adopt the method. Whenever you want to adopt particular control method, right, that method will come from the actual system characteristics only. That is, see, right, in today's session, I will try to explain concept through mathematics so that you will get more clarity. What is the beauty of mathematics you will get. Next, one more important thing is, before starting actual session, right, particularly for electrical scholars, mathematics, it is not a subject, it is a language. Each and every concept, each and every topic, we need to understand through mathematics, we need to analyze through mathematics, right? We need to develop the control logic through mathematics. If it depends on mathematics, see, burden on the scholar will come down. Everything. Mathematics will give clarity. Once you are having mathematics for a particular system, you will get more clarity about the concept, right? So before starting actual session, I want to ask one important question. What is the basic significance or what is the basic need of the controller? What it will do controller? Suppose I want to control the PMSM machine. What it will do exactly? Controller. Not only for PMSM, in general, in electrical system related case, take any system related case, what is the need of controller? What it will do exactly? Desired output. Okay. Any other? Any desired output? What is the need of controller? Try to reduce the error. Okay. Any others? Okay. Any other? What is the need? See, my job is, I'm telling, my job is I will try to mostly concentration on mathematical model and control point of. Madam will take care, Professor Rukmini Datta will take care about the design part. Right? There are three parts are there in this workshop. One is design of the PMSM machine. Another one is developing the mathematical model of PMSM machine and developing the control methods, field orientation, director control and model P2 control method. There are three categories are there in this workshop. So complete morning session will take care by the Professor Rukmini Datta. She will concentrate mostly on design of the magnetic circuits. My job is explain the significance of mathematical model and simulation part as well as director control FOC DTC method I will try to explain. So question is, what is the need of controller, particularly for electrical system? Desired output. Okay. See, thing is, if you take any electrical system, by nature, all are in nonlinear condition. This is a very important thing. See, even though by taking proper precaution while designing the machine, we cannot develop linear systems. That is the issue. You got my point? Even if you take PMSM machine, DC machine, synchronous machine, induction motors, basically all are nonlinear in nature. Right? By adopting the proper controller, we can bring into system into linear. That is what we are doing in field orientation control. Once system is linear, advantages particularly in aerospace application, electric vehicle application as well as in robotic application, their requirement is instantaneous torque control is their requirement. Right? See, if you are unable to control torque instantaneously, we cannot control speed or position instantaneously. See, what is the Newton's law? See, if you want to do something, it required force. If you want to change the state of the object according to Newton's law, it required force. In case of drive mechanism, see what is the basic definition of the drive? Drive is a mechanical energy producing device. Whether it is electrical drive or mechanical or hydraulic drive, basically drive is a mechanical energy producing device. By using this mechanical energy, we can pull, push, we can lift, right, based on the application requirement. We can roll the material also. Clear? See, important thing is, see, whenever you want to model something, first we should know the characteristics of the actual system. Whenever you want to understand the characteristics, we need to take mathematics. By taking in first, see, up to 4 o'clock, I will try to explain key points. I will try to explain the what is the philosophy behind the need of modeling. Once you know this philosophy, it is not a big deal for electrical scholars to develop the simulations. There are standard universal equations are there. If it depends on the universal equations, right, it is not a big deal. Many of the scholars, they are thinking that, sir, I am unable to develop the field orientation model, Simulink model. I am unable to understand the DTC, MPC methods, right? These all methods, they are proposed based on the actual system behavior. Without knowing the system behavior, we cannot, right? See, the need of controller is practically our systems, DC machine, induction motor, synchronous machine, all special machines, SRM, PMSM machine, BLDC, all are in nonlinear nature. Now question is, how we can say it is nonlinear? What is the base? How we can decide system is a linear or nonlinear? Anyone? Anyone else? See, whether student is good or not, how we can decide based on the CGPA. CGPA is the outcome of the performance. You got my point? See, with respect to motor side, what is the outcome? What is the expected output parameter of the motor? Torque. Based on the torque profile, we can decide order of the system. Right? We don't have any option. We don't have any freedom. Right? See, particularly see, as a faculty, what we'll see while deciding the project groups or while deciding the something, right? We'll take priority of the CGP only. No option for us. Right? CGPA is the outcome of the student performance. So, as an electrical scholar, whenever you want to control something, you have to understand what is the expected output of the system. Right? Basically, motors are torque producing device. Any motor, whether it is a DC motor or induction motor or synchronous machine or PMS or any special purpose machine, basically motors are torque producing device. Right? Based on the torque profile, we can understand whether it is a linear mode or non-linear mode. We can easily, without any control mechanism. See, all systems basically are in all are in non-linear nature. Right? First, we'll try to in first say this session. I will say in this session. First, initially, we'll try to understand how to extract the mathematical, how to extract the order of the various electrical machine. We'll try to concentrate. After that, whether it is a linear or non-linear, we'll try to identify. It is a complicated system, right? What are the challenges, right? How to overcome? How we can overcome our system? Our system is a complex system, AC system. How we can overcome? It is a non-linear system. We need to adopt. Initially, we need to adopt transformations. Transformations will not give 100% solutions. Many of the scholars, they are thinking that by adopting Clark transformation, Park transformation or cross transformation, problem will solve. These transformations will reduce the complexity, but it will not bring the system from non-linear to linear. This is very important. Please try to understand. Transformations never will give solutions to convert the non-linear to linear system. You need to adopt technique, engineering technique, that is called scheme, control scheme, field orientation scheme. It is a very beautiful scheme, right? By adopting field orientation scheme, what will happen? Complex system, AC system, induction motor or any other motor characteristics will transfer from higher order to first order, linear mode. First order nothing but linear mode. Once it is linear mode, instantaneous control is possible. Instantaneous control is more demand in robotic application, aerospace application, as well as wherever you want to change the dynamics of the machine instantaneously, speed or position, right? It required your torque must be in linear mode. If it is not in linear mode, it will take delay. Settling time will take time. System will not settle immediately. We cannot change the position or speed immediately if it is in non-linear mode. Clear? So, see, first in today's session, what is the need of electric motor in transportation application? We'll try to focus. After that, see, whenever you want to control the motor, right? As an electrical scholar, you need to identify control variables. System to system control variables, it will change. But our system is electric drive. Whether it is a DC motor or AC motor, any electrical machine, if you adopt for producing mechanical energy, it will come under electrical drive category. In electrical drive category, we see there are two standard control variables are there. What are the standard control variables? Beyond that, nothing. We cannot do anything. You have to concentrate always, whether it is FOC or DTC or MPC, right? You have to target always that particular variables, right? Anyone, what are the control variables in electric drives? What we are going to target? Flux and what is the reason? Flux and torque, these two are the target variables. Whether it is a DC drive or AC drive or special machine also, we don't have any option, we don't have any freedom, right? Why we need to target torque and flux? Anyone? You got my point? Question, this session, please try to understand, you should not feel it is only one direction. Energy should be travel bidirectional, right? That's why people, they are adopting electric drive in vehicle application. Advantage is whenever you want to deaccelerate, you need to operate machine in generating mode. Energy is coming back and, right, delivering power to the auxiliary batteries. That option you won't get in IC engine based vehicles, right? That is the special feature you can get if you adopt electric machine in vehicle application. Anyone? See, my question is very simple. Control variables for electric drive is torque and flux. Our target variables are always torque and flux. What is the reason? See, with respect to customer point of view, with respect to application point of view, their requirement is always position and speed. They don't bother about how much torque is generated by machine, they don't bother. Right? As an electrical scholar, you need to bother about what is the torque generated by the machine. But with respect to customer point of view, right, he will see always what is the speed of room fan. They will bother about the speed only. They are not bothering about how much torque is generated by the machine. You got my point? So whenever you want to satisfy the customer, essential thing is, as an electrical scholar, you need to take care about what is the torque generated by the machine. Reason is, position is depends on the speed. Whenever you want to change the speed, position of the shaft, you need to change the speed. Whenever you want to change the speed of the shaft, what is the cause component? As electrical scholar, if you depends on the cause and effect relationship, as per Newton's law, it is not a big deal to understand what is the input to the controller, what is the expected output of the controller. It become very easy. Why? Because in next session, we need to understand the control hierarchy. Next topic is control hierarchy. Control hierarchy is fixed. In our campus, what is the hierarchy? We are following. Any institute, they are following hierarchy. What is the hierarchy? What is the hierarchy? Director, deans, next. HOD, fine. Next. Faculty, next. Your hierarchy is fine, but sequence is not correct. Top priority is students. You got my point? Top, based on the student requirement, right? See, they will, HOD or timetable in charge, they will take care about the faculty. They will allot a particular faculty to meet their student requirements. To meet their requirement, they will allot a faculty, right? Faculty has to satisfy the student requirement. Otherwise, students will struggle like anything. If students are struggling, immediately HOD will see, students will give complaint on the HOD, HOD will give complaint to the deans, deans will forward the complaint to the director. This is the procedure. Right? Top priority is you need to take care about the students. But actually, director is not working effectively. Deans are not working effectively. Most of the time, see, students are working effectively. As a faculty, you have to show the path to minimize the time. Whenever you want to transfer the energy, all materials are available in YouTube, right? But as a faculty, you have to show the shortest path to reach the destination with less time. So that student will not feel as a burden. Right? We can easily transfer the energy to the students so that students feel very happy, right? If you provide shortest path. As a faculty, I will depend always on mathematics. I don't have any option. Mathematics and characteristics. If it depends on mathematics and characteristics, it doesn't require any textbook. No need to follow any textbook, right? By taking 2 or 3 examples, we can easily explain the concept, right? In today's session also, right? Based on the Newton's law, we can understand, see, what are the control variables, particularly in electric drive, will identify. These variables will not change. Even though your system is, even though your mission is changes, target variables will not change. Please try to understand. This is very important, right? See, reason is, and basically motor is a torque producing device, right? See, by by controlling the torque, we can able to control the position or speed. That's why as an electrical scholar, you need to target torque. But issue is, while controlling the torque, by by adopting the flux control or field control, advantage is number of variables involved in the torque expression will come down, right? So uh, I will tell what is the significance of. Initially I asked controller, right, question, still it is not completed. Why controller is required? Controller, by adopting the controller, with controller and without controller, difference is system order is changing. Initially all are in nonlinear mode. By adopting the control mechanism, order will get effect. If order is decreases, definitely dynamic response will improve. The ability of the closed loop system is, right, it will reject the disturbance. Primary significance of controller is it will minimize the overall system order. If order is decreases, control become very simple. Dynamic performance we can improve, right? So example, simple example, what is the mathematical model for, see, by taking this example I will try to explain. This is called universal torque expression. This expression is applicable for all electrical machine except reluctance machines, right? DC machine, this equation is applicable. Induction motor also, this equation is applicable. This equation, see, this equation is applicable for all electrical machine. It is called universal torque expression. This expression is applicable except switch reluctance motor or reluctance torque machine. Except this one, for all other machines this expression is valid. So by using this equation we can understand, right, what is the need of controller, particularly if system is a complex system. If it is a AC system, what are the challenges? Why? But see, even though complexity is more, right, why people are liking AC machines, right? We'll by taking examples we'll get more clarity about this part. After that, see, before break I will give small assignment. You have to do simulation so that you will get clarity what is the significance of transformation. Many of these scholars I am telling still they are getting confused. What is the basic difference between the magnitude invariant and power invariant in transformation, right? At the end of today's session you will get clarity what is the difference between magnitude variant and power invariant in transformation technique, right? Next, one more important thing is whenever you are adopting transformation technique, without knowing the nature of the actual system we cannot. Please try to understand, transformation methods also completely, the logic behind to develop the transformation also, it is completely based on actual system characteristics. If your system is a 3-phase system, you need to adopt 3-phase to 2-phase conversion. Suppose your system is excited with pure sinusoidal signal, fine. According to that, you need to take 0 sequence component 0 in transformation technique. Otherwise, if your system is excited with non-linear signals, right, non-sinusoidal signal, right, I want to ask one important. In between, I will ask so many questions so that, why? Because afternoon is a very tough time to transfer the energy to the audience. Very big challenging after lunch break. So that I need to ask questions. Why sinusoidal signal is reference for electrical scholar? What is the reason? Why we need to adopt sine signal? Why we need to apply sine signal to the motors? Any reason? Why sine is reference for electrical scholar? Why not triangle? Why not trapezoidal? We are not applying trapezoidal or triangle waveform. Our requirement is always sine. What is the reason? No, Fourier series mathematics will come later. First we need to take care about the physical system behavior. Sorry? Anyone? That is mathematics. We are not applying integration, differentiation to the fan, right? We are applying sine signal. Simply we are applying sine signal. Hmm? Hmm. Generation? Hmm. Correct. See, for electrical engineering, sorry, for mechanical engineering, what is their reference for mechanical engineering? Wheel. Circle is their reference. Why? Why our vehicle tires are in circle shape? Minimum losses. Centrifugal forces acting on rotor surface. If rotor core is in circle shape, your wheel is in circle shape, centrifugal forces acting on the rotor surface is very less. Friction is also very less. Right? So that we can minimize the losses. If losses are less, reliability will increases. More time you can operate. Whenever you want to operate the same system, more time you need to take care about heating effect. Everything, all systems are designed based on the heating effect, minimizing the heating effect. No option. All electrical systems, mechanical systems, electronic systems, see, they will design to minimize the heating effect. Right? So, if your rotor core is in circle shape, we don't have any option. You need to arrange the conductor in circle shape. If conductors are in circle shape, right? See, if conductors are arranged in circle shape, right? For understanding, there is a north and south pole is there. This is the nature of magnetizing flux. This vector, this is the nature of magnetizing flux. Clear? This vector is looking like constant with respect to participants. Now, see, the length of this vector is looking like constant, but if I rotate in circle shape, right, with respect to me, so if I stand here, this vector is looking like dot initially, right? If I stand here exactly here, this vector is looking like dot. If I come here, vector length will increases, right? Exact perpendicular maximum, vector length looking like maximum. After that, if I complete off cycle, again it will come back to 0. What it means? See, whenever person is rotating with respect to audience, it is looking like constant. Vector length is looking like constant. But see, when conductor is rotating in circle shape, pure circle shape, right? Same vector is looking like sine waveform. Magnetizing flux is looking like, with respect to rotating conductor, it is looking like alternating. Circle is nothing but, sinusoidal is nothing but less heating effect. Whenever your conductors are rotating in pure circle, heating effect is less. So that we can operate more period, more time. Reliability is good. Right? If it is rotating in circle shape, we'll get sinusoidal. No option. Right? That's why this is about generating mode. If you apply sinusoidal signal to the machine, your rotor also rotating in circle shape, pure circle. Nothing but losses are less. You got my point? Sine, both. If conductor is rotating in circle shape in generating mode, it will produce sinusoidal voltage. Whenever you apply the sinusoidal voltage to the system, your mechanical system will rotate in pure circle, so that heating effect is less, reliability will increases more. That's why, see, electrical engineering or mechanical engineering, their reference is circle. Circle is nothing but technically sinusoidal, Vm sin omega t or Vm cos omega t. Right? So, by taking this universal equation, initially we'll try to focus on what is the order of the actual system. Based on the potential element, what is the output of the element, based on the output element produced by the system, we can decide the order. Right? So, here whenever you want to decide the order, as an electrical scholar, you need to understand how many variables are involved in the equation. Right? In case of DC machine, the beauty of DC machine is, because of commutation action, this delta become 90. Am I correct or not? Delta, space displacement angle, this is about magnetizing flux, this is about armature flux. Right? What is the space displacement angle? 90. Is it variable or constant? It is a constant. You need to take precaution. By taking precaution, by taking interpoles, by taking right, proper precautions, even load torque is increases, even burden on the machine is increases, this angle will not change. Like that, you have to design the machine. By taking care about the design, right, we can maintain constant. If it is a 90 degree, advantage is, what is the advantage? How many variables will come down? xi s, xi r. This equation we can replace. We can write T equal to xi s is nothing but stator flux, xi r is the rotor flux, right? Xi s is mainly because of field current. So, right, stator flux we can write in terms of field current, rotor flux we can write in terms of armature current. These two are responsible for producing the field flux as well as armature flux, right? So finally, how many variables are there? These two components are flowing through the different windings, field winding and armature winding, different coils. These two are called state variables. These two currents cannot change instant to instant without adopting control mechanism. You got my point? Why? Because time constant is different. By adopting the control mechanism, we can able to minimize the order so that time constant will come down. With controller, without controller, time constant it will regulate. System response will regulate. So by taking this equation, now what is, how many variables are there? There are two variables. What is the order? Second order. Is it linear or non-linear? Basically it is non-linear. Now you can, how we can convert non-linear to linear? By nature, DC machines are, motors are in non-linear nature. How we can change the mode? How we can change the order of the system? See, if it is a non-linear, it is not so easy to improve the dynamics instantaneously. Then no option. We need to go for control mechanism. We have to adopt method. By using concept, by using different schemes, we can able to convert from non-linear to linear. Right? What is the method in general we are adopting? There is a popular method is there for DC machines to convert non-linear to linear. What is that method? You know about armature voltage control method? You heard? What is the beauty of this method? In armature control method, what is the first step? We are, throughout the operation, we are maintaining field current as a constant. If it is a constant, see, we not only maintaining constant, we are maintaining the field current at rated condition. Maximum flux we are maintaining in the system, right? So that field current is constant and rated value, so that torque equation become, so armature voltage control method. This is the logic. This is the control scheme. Many of the scholars, they know the method, but they are not concentration on what the logic behind this method. You have to analyze in detail, so that you will get clarity about what the significance of control system. Right? Whenever you want to adopt armature control method, it is a scheme, control scheme. You should know actual system behavior. Based on the actual system behavior, right? Basically it is in nonlinear condition, right? So by maintaining this component as a constant, by regulating, by maintaining IF as a constant, we can convert it to nonlinear to linear. But the issue is which method we need to adopt? Armature control voltage. Right? If you adopt armature control voltage, nonlinear system become linear. Next, one more important thing is armature control method, right? By maintaining field current in DC systems are very easy. Right? So whenever you want to maintain IF constant, you need to apply constant VF across the terminals. Right? Now, see, tell me, what is the order of, now DC motor basically in second order. What about order of the induction motor? 7. Why 7? Why order is 7, induction motor? See, stator side, this is called resultant stator flux. After interacting A phase, B phase, C phase, you will get lambda S. After interacting rotors, A phase, B phase, C phase, you will get lambda. Many of the scholars, they are getting confused why rotor circuit is a 3-phase circuit. Even though it is looking like squirrel cage, right? If stator side number of poles are 4, automatically same number of poles will induce on the rotor side. If stator side, if you excite with 3-phase system, rotor side also 3-phase currents will flow. 3-phase voltages will induce on the rotor side. Three-phase currents will flow on the rotor side, but frequency different. Frequency, rotor current frequency, rotor voltage frequency is completely different than stator. Right? If it is a three-phase, stator side winding is in three-phase circuit, rotor side also you will get three-phase voltages and three-phase currents. Clear? Now see, so stator side three-phase, 3 variables are there. Rotor side also 3 variables are there, 3 plus 3. Next, one more important thing is, in case of induction motor, we don't have any commutator brush combination. We cannot maintain delta 90 degree. Because of this reason, delta is also variable in case of AC systems, right? So it is also variable. So 3 plus 1, what is the order? 7th order. But why people are motivating induction motor? What is the reason? Even though it is mentally it is a very weak, right? Torque profile is in 7th order. Why people motivating all industry 90 to 95% application, they are adopting induction motors only. Applications of DC motor, except India, in foreign countries no one is using DC machines. In traction application also, right, coming 4 years their target is replacing DC series motors with induction motor. Their target. Coming 4 years definitely they will replace DC series motors with induction motors using vector control methods, field orientation method. What is the reason? Main reason is induction motors physically very strong. No brushes, no commutator, machine size is also very compact, but DC motors are very physically very complicated, very lazy also, physically very, maintenance is more, brushes you need to take care. The lifetime of induction motor is 70 to 80 years. Continuously you can operate 70 to 80 years, no issue, no maintenance. But if you take DC machine, issue is maintenance is required. We cannot operate more than 15 years. Lifetime, maximum lifespan is for DC motor is 15 years, 1-5. For induction motors, 70 to 80 years we can utilize. Right? Next, come to conventional synchronous machine. What is the order of conventional synchronous machine? What is the torque profile? What is the torque profile of synchronous machine, conventional? See, our main focus is, our main final objective is synchronous machine, PMSM machine. First, see, if you want to understand the characteristics of the PMSM without knowing the fundamentals, it is very difficult. It is a 4th order system. Rotor poles are excited with DC, conventional. Current, it is not a variable. Under steady state condition, current will not regulate. Right? So stator side three variables are there. Rotor side there are no variables. Right? Next, delta is a variable in case of synchronous machine. 3 plus 1, it is a 4th order. So finally, even though it is a 4th order, compared to induction motor, order is less, but practically conventional synchronous machines, motors no one is using in practical application. Reason is physically very big. Brushes are there. If you want to transfer the energy from DC to rotating part through brushes, maintenance is required. Speed constraints is there. We cannot go beyond the 1500 RPM. Conventional synchronous machine. There are a lot of limitations are there for conventional synchronous machines, right? So now there are 3 machines. Beyond that, nothing is there. Please try to understand. These 3 operating principle of these 3 motors we can understand by taking single equation. There is a universal equation is there. Speed expression is there. If it depends on the speed expression, we can understand what is the logic behind each machine, right? Now I want to ask one important question. The expected output of any motor is a torque. If you want to produce the torque, what is the essential condition you need to satisfy? There is a logic is there behind all machines. Behind the torque producing principle, concept is same. DC motor concept is same. Way of generating torque in all machines, logic is same, principle is same, but procedure is different. If you want to produce the twisting force, what it required? what it required in all machines, DC machines, induction motor, PMS, even PMS also, there is a common principle is there. What is that logic? Interaction, relative motion must be 0. Relative motion between the xi s and xi r must be 0. At any moment of the time, at any instant of the time, you need to take care about the relative motion between the stator flux and rotor flux. Relative motion is 0 with respect, see what is the speed of participants, all are sitting, speed of the participants 0, speed of the right faculty also 0. So what is the relative motion between the faculty and participants? 0. So that we can interact effectively. Otherwise, if faculty is stationary, participants are running, we cannot transfer the energy. We cannot convert also. Whenever you want to convert energy, first you have to transfer the energy. First, initially, you need to transfer the energy. After that, based on requirement, we can convert the energy levels. That is what we are doing in all electrical machine. In DC machine, your commutator will take care about the relative motion. In case of induction motor, your slip will take care about the relative motion. Even in case of synchronous machine, your synchronous reactance will take care about the relative motion. All will take care. Right? In all machines, common logic is you need to take care about the relative motion between the stator flux and rotor flux. Relative motion must be 0. If relative motion is 0, both will interact based on the requirement. It will produce the twisting force. Now question is very simple, right? My question is very simple. Take no load condition and load condition. What is the difference between load condition and no load condition with respect to magnetic circuit point of view? Anyone from the participants? You got my question? First try to understand question. This is important. Later you can answer. Sorry? No, relative motion will not disturb. If relative motion is disturbed, everything will spoil. Machine will not generate the torque. Relative motion will not get disturbed at any moment of the time. With respect to magnetic circuit, flux is constant, but flux density will get affected. This is important. Please start understanding. See, I think, see in undergraduate course, I think while studying the electrical machine, uh, you have gone through the Fleming's left-hand rule, right-hand rule, right? See, the principle, the logic behind to propose, these all are methods. They have proposed this method, Fleming's left-hand rule or right-hand rule. See, these all are methods they have proposed based on the basic principles of the machines. If you follow this method, what will happen? We can minimize the time. We no need to know, see what is the happening inside, what is the direction of current, direction of flux density, whether flux density is changing or not. We no need to bother about. Simply by applying Fleming's left-hand rule, you will get what is the direction of twisting force. Right? See, Fleming's left-hand rule or right-hand rule, they have proposed based on the flux density concept. Right? Flux density is a uniform in no load condition. Under no load condition, flux transferring from north pole to south pole, if you verify, you can take any sample in between. Under north pole influence side or south pole influence side, you can take any sample and verify the sample flux density per flux per area. If you verify, it is a uniform. But once you apply the load, flux density will get disturbed. Flux density become non-uniform. Actually, non-uniform flux density is required to produce the twisting force. Please start understand. But issue is sometimes your core may enter in saturation. If you apply more load, what will happen? Why machine is not generating required torque? Reason is flux density, it is going beyond the rated value, right? Even see, it will enter in saturation. Once flux density is enter in saturation, machine will not produce the torque. Even if you increase the burden on the shaft, machine cannot produce more amount of the torque. That is the issue. If torque is increases, flux density changing. If flux density is increased at one point, see one zone, what will happen? Upper zone flux, let us assume that flux density is increasing, bottom flux density is decreasing, what will happen? Upper side core will enter in saturation. Your magnetic circuit may enter in saturation. If it is entering in saturation, definitely a machine will unable to produce required torque. This also challenges. That's why we should not apply the load torque beyond the 120% or 130% of the rated torque, right? So here issue is, finally from this slide, what are the conclusion we can understand? See, the order of DC machine is very good. It is in second order. By adopting simple armature control method, we can bring into linear mode, right? If it is a linear mode, we can improve the dynamic response instantaneously. But problem with induction motor and synchronous machine, order is more very complicated. If you want, whenever you want to control the torque or flux, it required more number of feedbacks. If torque is depends on 7 variables, we don't have any freedom. You need to take 7 feedbacks to control the torque effectively, right? In case of synchronous machine, order is 4. We need to take 4 signals feedback from the system so that we can control the torque. If number of feedbacks are more, design of the Kp and K value, it is not a simple task for if number of feedbacks are more. If number of feedbacks are increases, control point of view, it is very complicated, right? That's why. But thing is, people are motivating towards AC machines, induction motor. Why? Because no brushes. Reason is, right, no brushes. Before 1970s, most of the engineers or researchers, they design engineers as well as control engineers, they were focusing on control the DC motor before 1970s. After 1970s, field orientation method, vector control method they have proposed. Under vector control in 1970s, they have proposed field orientation control in 1970s. After proposing field orientation method, the behavior of the induction motor, characteristics of the induction motor is similar to DC machine. It will offer same character. Whatever characteristic is offered by the induction DC motor after armature control method, same profile you can expect even if you adopt induction motor in practical condition. That is the beauty of field orientation method, right? But issue is, see, mentally induction motor is very poor. Physically DC machines are very poor, but industry people, they are giving top priority for physical characteristics. Whether person is physically fit or not, they will check. If student is fit, even though he is average student, he can able to sit in the exam hall continuously 3 hours. He can able to at least write 3 or 2.5 questions. He can get minimum C or B grade. Even though person is excellent in see, subject wise he is excellent, but he is unable to sit in the exam hall because of physical characteristics. He cannot write exam hall continuously more than half an hour. What is the issue? He cannot get any grade. After examination he will not get. But good thing is he can answer all 5 questions, but he cannot get grade. So because of this reason, industry people first they will give top priority for physical characteristics. So physically who is fit out of these 3? Induction motor. Later I will explain what is the issue with induction motor. Why induction motor they are going to replace with PMSM machine. I will explain in detail. You got my point? See, first initially their target is induction motor. Initially they will focus on induction motor in 1970s. Why? Because system, it is a very rugged system. No maintenance, very compact. Particularly in electric vehicle, aerospace application or satellite application or submarine application, there is a limited space is available for drive system. Right? With limited space, if you want to produce more power, you have to go for PMSM machine. No option. Right? Clear? So this all are about torque equation. Later after completion of modeling you will get clarity about. See, by seeing all are looking like very complex, but if you depends on the mathematics step by step, if you go step by step, definitely you will get clarity about this equation. Finally, right? This is about induction motor equation. If you observe the induction motor torque profile, there are 7 variables are there in terms of currents, right? 7 variables. Now if you take synchronous machine, conventional synchronous machine, there are 4 variables are there. If you take permanent magnet synchronous machine, final torque expression, there are 4 variables are there, right? So PMSM also, it is a 4th order system, right? What are the challenges? See, before explaining these challenges, everything, I want to ask one question, one important question. Why? Because many scholars already, they are going to submit, some scholars, they are going to submit thesis, some students already completed PhD, right? What is the need of transformations? You know about transformations? 3-phase to 2-phase conversion. What is the need of transformation? To reduce the complexity. No. This one, complexity will come later. Sinusoidal to DC, no. There, this all are, see, if you adopt transformation, finally, 3-phase to 2-phase variable, right? 2-phase AC to 2-phase DC. This is all are fine. What is the basic need of transformation? No. Understand the behavior very good. Any other? Where they are adopting these control transformations? With respect to control point of view. These transformations are so important with respect to control point. With respect to control point, what is the objective? Whenever you want to control something, first you have to get the feedback. Without taking feedback, we cannot control effectively. You got my point? By adopting transformation, you will get actual system behavior with less number of variables. You will get clarity about, see how system is behaving in detail, you will get clarity, right? See, this is a very popular technique, engineering technique. What is the use of this technique? You know about this one? This is corner mirror. Particularly, see, in hill areas wherever sharp curves are there, they are adopting this technique. You got my point? What is the use of this technique? It is a technique, engineering technique. It is like transformation. Transformation also, it is an engineering technique. What is the use? Mirror. This one, corner mirror. See, let us assume that, take example, here there is a sharp curve is there. Clear? So now this is the position of our controller technique. This is engineering technique, right? Now our reference person is here. There are 2 vehicles are there. This is A vehicle. This is about B vehicle, right? Our reference person is sitting inside the A, right? Now see what he will do. This reference person, whenever, see, let us know that there is no technique, this one, what will happen? What is the option for controller? Whenever he want to turn the path, no option, there is no mirror, he has to reduce the speed. If there are n number of curves are there, wherever curve is there, he has to bring the speed less, he has to reduce the speed. So see, without knowing the information, also we can operate the system, we can operate the vehicle, but issue is it will take long time to reach the destination. You got my point? See, without transformations also we can, but thing is dynamic response will not improve. We cannot, see, it will take long time to reach the steady state. So by adopting this curve, by adopting the, wherever curve is there, sharp curve is there, by adopting this engineering technique, first thing is, we will get information. Whenever we are crossing the curve, before crossing the curve, you will get information. You can get the information whether any vehicle is coming opposite way or not, you will get clarity. If there are no opposite vehicle, you no need to minimize the speed. You can go as possible as speed, you can go and you can reach destination. If any vehicle is there, you have to reduce the speed and you have to control the vehicle speed and you have to cross the vehicle, right? So here mirror is a technique, it will give information about actual system, information it will give, it will pass to the controller. Your transformation technique also will pass the information to the controller. Actual signal, actual system behavior, right? It will transfer to the controller without losing any property. You got my point? If opposite any car is there, it reference person can observe whether it is a car or truck, he can observe. It will give, it is a mirror, same reflection only, right? Any bicycle is there, no need to reduce the speed, you can go, you can go. Any big truck is there, you have to stop. Any luggage, big truck with luggage is there, right? Whenever you want to climb, you have to you have to stop the vehicle and you have to allow big truck first, then after that you have to travel. Am I correct or not? This is the standard procedure they are following in transportation case, right? So here also, by using this transformation technique, Clark transformation, Park transformation, cross transformation, right, we can without losing any property, we are getting the information from the complex system. Basically, see, our system is a complex system, it is a three-phase system, right? See, if it is a three-phase system, what we are doing, you need to adopt, no option, you need to adopt complex vector concept, that is called space vector technique. You need to adopt this transformation. The logic behind this transformation is space, based on the space vector technique they have proposed this method, right? What is space vector technique? What is space vector technique? I'm not talking about PWM. Space vector PWM is different. I'm talking even space vector PWM is PWM concept they have proposed based on the space vector technique only. Space vector technique, other name is complex vector representation. Any vector in space we can represent into two variables. One variable we can take on x-axis, another variable we can take on y-axis. You got my point? Let us assume that our system is a complex. In our AC system, the nature of magnetizing flux is always rotating in space. It is always rotating with supply frequency, speed. If supply frequency is more, speed of the vector is more. Clear? Now, thing is, right, this vector we can represent, right, alpha axis or effect of this vector we can express in terms of alpha axis as well as beta axis. That is called complex vector representation. What is the mathematical operator for complex vector representation? E power j. You know about this operator? It is a very beautiful operator. By adopting this operator, we can understand what is the logic behind cross transformation, Clark, Park, everything we can understand. Simple. Only your job is you need to, this is important, plus or minus e power plus or minus j. Next, here angle, how much angle? Theta. By using this operator, we can convert, we can see the nature of complex system. Our system is a three-phase or multi-phase, more than, even if it is a five-phase system also, right? By adopting this transformation, finally we can transfer the signal into two variables. You got my point? Now question is, see, many students or participants, they are interested to understand the field orientation control, direct or MPC control, predictive control. See, whenever you want to develop simulations in particular control, why this logic is required, why these transformations are required, are so important. Why you have to think, so that you will get more clarity. Why, what, how, these three parameters you need to take. As a research scholar, if you take care about these three parameters, your problem becomes simple. Clear? Now question is, my question is, see, I will explain using this operator how to convert three-phase to two-phase, power invariant, magnitude invariant. Anyway, today assignment is you have to do this simulation in hostel, right? You have to develop this simulation for three-phase to two-phase, magnitude invariant and power invariant. You have to show the results by tomorrow or anyway day after tomorrow holiday, right? You can show me on Thursday. Any doubts are there? Will help. Before doing vector control method, field orientation method, transformations are so important, right? Now, my question is, why transformations are required? Okay, fine. See, by using transformation, you will get clarities, right? We can minimize the variables. It is fine. But with respect to control point of view, how this one, how what is the significance of this transformation? Physically, please try to understand. As an electrical scholar, you need to understand what is the actual system behavior. This is so important. Based on the actual system behavior, see any needs are there, actual need is there, engineer, they have to think. Based on their needs, you have to work so that we can solve the issues. Need is, identify the need is a very big challenging for engineers. Based on the need, we can summarize the problems. If problem is a really serious problem, you have to take care. If it is a problem is not that much, you can ignore, no issue. But in AC systems, all AC systems, there is a big issue is there with respect to control point of view. What is the issue? Time varying, later, time varying inductance, later will come. Time varying inductance, later. Hmm? Coupling, coupling is, anyway brushes are not there, definitely we cannot maintain 90-degree. Decoupling is not possible in any machine. Anyone? Controllers will come secondary. I'm telling you. See, try to don't focus on control side. First, you need to. This session is exclusive for understanding the actual system behavior, right? So, how system is behaving, right? What is the need of engineer, control engineer with respect to actual system? If you understand what is the, this one today philosophy behind this concept, right, you will get clarity about what is the need of transformation in AC system. This transformation technique is applicable only for AC systems, complex system, not for DC or not for two-phase system. It is applicable for three-phase or five-phase or n number of phases. What is the problem with three-phase system? Hmm? Mutually independent. Both magnitude and angle is control. Oh, no. Hmm? No. See, in case of DC machine, there is a separate path. We don't please start understand. If you take any machine, finally there are three circuits are there. Inherently, there are three circuits are involved in the system. One is magnetic circuit, that is called field circuit. Another one is called armature circuit. Another one is called mechanical circuit. Right? Armature circuit, field circuit, and mechanical circuit. You got my point? See, before closing today, we'll try to develop one model based on these three circuits. Example, we'll take DC machine. Right? Initially, we'll take DC machine so that some students are from undergraduate only. Right? So that they will get more clarity. Right? As a faculty, I need to satisfy everyone. From basic ground to right required level, I have to teach. Right? See, issue is take DC machine. In case of DC machine, physically there is a separate path is there for field current, and there is a separate path is there for armature current. Am I correct or not? See, by connecting ammeter here, you will get clarity about field current. How much field current is flowing to the system, you will get information. Even if you connect one more ammeter in series with armature, you will get clarity about how much current is flowing to the armature circuit you will get. Once you know the clarity about the actual system currents, it is not a big deal to control. But if you take AC system, induction motor, take induction motor, what is the nature of current passing, what is the nature of IS? What is the mathematical operating principle of induction motor, operating principle of transformer, same. You got my point? So what is the mathematical model for input current in case of transformer? I1 equal to I0 plus I2 dash. So from this equation, what is I naught? I naught equal to I mu plus IC, core loss component. Compared to magnetizing component, core loss component is only 2 to 3%. You can neglect. So what is the resultant input current? So input current is nothing but I mu plus I2 dash. Clear? Input current. See, I will rewrite here. Input current equal to I mu plus I2 dash. What is I2 dash? I2 dash is nothing but load torque. Depends on the button on the shaft, this current will regulate. Nothing but, see, the main responsibility of I2 dash is it is a torque producing device. You got my point? I2 dash is a torque producing device. What is function of I mu? It is a flux producing device. Finally, see, the main object of any electrical machine, what we are doing is we are supplying two different nature of the current. One is for magnetizing poles, another one is producing the twisting force. Nothing is there. Beyond that, nothing is there. Right? In case of DC machine, to get the required, based on the customer requirement, to get the required position or speed, what we are doing, we are generating the torque. Right? To generate the torque, you need to take care about the IA. Based on the strength of the current drawn by the machine, we can decide what is the torque producing by the machine. IA is nothing but it is a torque producing device. IF is flux producing device. This one, the main responsibility of IF is it will magnetize the core. IA is it will produce the twisting force. Right? So in DC machine, there is a physically there is a separate path is there for IF and IA. But AC machine, if you verify, right? Even though if you connect ammeter here, what you will get what is the resultant strength of the current drawn by the machine. You cannot get what is the strength of magnetizing current drawn by the machine independently, right? What is the strength of I2 dash, you will not get clarity. You got my point? That's why transformations are required. Transformations, after applying the transformation, you will get clarity about what is the magnetizing current drawn by the complex system, what is the torque producing device drawn by the complex system, you will get. Once you know the magnetizing current information and torque current information, it is not a big deal to bring the I mu and I2 dash based on the reference currents. It is not a big deal. By choosing proper Kp and K value, we can eliminate error. Nothing but reference current and actual current both are matching, then your speed will come to based on the customer required position. You got my point? Now you understood what is the need of transformation. Transformations will give clarity about, right, inherent current information you will get in detail. If you take input current, three-phase current, by taking three-phase current through ammeter, you will not get clarity. By applying the transformation, by applying engineering technique, you will get clarity about I mu and I2 dash. Right? Independent values you will get. But ammeter will give only resultant value of the input current. By applying the transformation, you will get more clarity about the I mu and I2 dash current. That is the significance. That is the significance about the transformation technique. Next, one more important thing is, see, main challenges in AC drives is eliminating. You need to focus on non-linearity. How many variables are there in the actual system? Torque expression you need to verify. If there are more variables are there, automatically control circuit become more complex. Issue is if control circuit is complex, see, execution time, particularly whenever you want to execute the logic in real time using real time controller, issue is computation time is more. We don't have option. You need to increase the sample time. You know about significance of the sample time? What is sample time? The rate at which we are executing the logic, right? See, if sample time is more, what is problem? Error is increases. See, in academics, what we are doing, we are taking feedback from the students after completion of the semester. Before last working day, the deans, they are taking feedback from the student. Who will get benefit? if you take more number of samples per semester, if you take more feedbacks from the student per semester, we can improve the quality of the education. Any issues are there, we can rectify. Right? Same, if you take more number of samples per second, we can eliminate the error. Sample time, it is not under your control. It is completely decided by the length of the sample time is decided by the length of your logic. Your logic is complicated, right? To solve a simple solution, to solve a simple problem, if you take complicated solution, sample time will increases, right? So see, if sample time, see your execution time is 10 microsecond, right? Sample time, you have to take at least 20 microseconds, fine, right? Sample time must be greater than your execution time. No option. Otherwise, if you take less sample, execution time is more. Within sample, your program is not executed, you will not get any outcome, right? See what industry, what controller is expecting, what parallel running module is expecting after completion of every cycle. If you go through this block diagram, you will get clarity. After, this is the logic. Please start to understand. This is the logic behind the advanced control schemes. Field orientation method, right? Variable voltage and variable frequency method, director control, MPC methods, right? So these logics through microcontrollers we can execute. After executing this logic through controllers, what you will get after completion of every sample time, what is the expected output? What your device will, parallel running is expecting pulse. Pulse, the expected output of the controller is pulse. Based on the requirement, based on the speed, by adjusting the duty period of the pulse, right, we can change the RMS voltage and frequency we can regulate. By changing the frequency and voltage, we can change the characteristics of the motor based on the load requirement. This is our load, right? Based on the load requirement, we can change the motor characteristics. This is a complete EV propulsion system overview, right? So our part is developing the logic. This is the logic, mathematic concept. By adopting this concept, what we can do is we can improve the motor profile to meet the load requirement. You got my point? First, see, important thing. What is the important thing in this block diagram? Anyone? What is the task? There are so many blocks are there, right? Electronic controller is there, battery is there, power converter is there, electric motor is there, right? So as a design engineer, which part you have to give top priority? What are there are so many blocks are there. What is the top priority block? That's what I'm telling you. You're always thinking about controller. Your focus is on controller. Top priority is how much burden is applied on the motor shaft. This is a motor shaft, right? This is the reference point. This is a reference point, right? With respect to this reference point, how much burden is applied on the motor shaft, you need to calculate. This is important. Based on the load requirement, right, you need to generate the twisting force. Torque we can control through power electronic module. We can generate and we can modulate based on the requirement. Top priority block is load. This is a top priority. This is a top priority. This is the rank 1. Right? So whenever you want to control motor, essential thing is how much burden is there with respect to, this is a reference point. With respect to this point, you need to calculate what is the burden applied on the motor shaft. You need to calculate. Once you know the burden characteristics, once you know the load characteristics, right, by using electric motor, we can change the torque profile. Load torque, TL, see, TL, it is not in your hand. The behavior of the TL is not in your hand. Please try to understand. As a controller, you need to satisfy the TL. If you want to bring your system into steady state, right, generated torque must match with load torque. This is the essential condition to bring your system into stable. Right? See, thing is, this is not in your hand. This is under your control. This machine torque, motor torque, we can control through power electronic plus controller, V by F, right? Variable voltage and variable frequency method, field orientation method, direct torque, or different methods by using without taking combination of power electronic and control method, we cannot change the torque dynamics of the AC system similar to DC machine. These two combinations are required. These two combinations are essential to change the dynamics of the AC system similar to DC machine. Practically, see, whenever they want to improve the AC system performance, benchmark is DC machine. But DC machines practically it will not come to the picture. But benchmark, torque profile, everything they will compare with DC machine only. Benchmark is a DC machine. But practically all are AC machines only. In EV application, aerospace application, all are adopting AC machines. Right? So, see, in this block, top priority is load. Second, what is the second priority? Anyone? Ranking. As a scholar, you have to decide the rank. There are so many subsystems are there in this block, in this system. Second ranking is motor. Based on the load requirement, based on the availability of the space, if space is sufficient, there is a sufficient space is there, you can go for induction motor instead of PMSM machine. You can go for induction motor. Next, another important thing is now there are a lot of techniques are there. Without permanent magnets also they are proposing techniques. Magnetless synchronous machines through induction principle. Right? Later, see if sufficient time is there, I will try to explain some of the techniques still under research level. Right? So, we are also concentrating on one machine, right? Without brushes, right? Without brushes, without permanent magnets, we are try to develop one machine. Later, I will explain the concept. If time is there, I will try to explain. Right? Already we collaborated with one industry. Initially they agreed, right? Officially we have not completed any MOU. Initially they agreed. Later we'll see what will happen. We don't know. Industry people, they will not. Initially they will show a lot of interest, but when come to the documentation, they will afraid like anything. Okay. We'll later, if time is there, sufficient time is there, we'll discuss in detail. Right? So by taking second priority is motor. How they will select the motor? Selection of motor is mainly based on how much power is required, power levels based on the available space. Right? More power requirement is more, less space is available. We don't have any option. You have to go for special machines. Special machines, nothing but what is the advantage of PMSM machine? Now question is, see, why PMSM machine will PMSM machine efficiency is more? What is the reason? Rotor winding. Okay, that is fine. Technically, what is the excitation is not required. Sorry, why efficiency is more? Less losses. You know how they will calculate efficiency in general? You know about power factor? Can I ask one question? What is the significance of power factor? If you take power factor, there are no units for power factor. It is a factor, right? So by using power factor, we can understand what is the rate of energy conversion. If power factor is 0.9, energy conversion rate is 90%. If power factor is 0.98, see, energy conversion rate is 98. You got my point? Based on the power factor, we can decide what is the conversion of energy rate. Why efficiency of the PMSM is more compared to induction motor? Reason is, what is the reason? Ideally, I'm telling, ideally, required magnetizing current under no load condition is 0. What is the nature of magnetizing current? practically, if you take an induction motor, what is the nature of magnetizing current? It is always working perpendicular to the voltage. If you verify the position of the magnetizing current, it is exactly perpendicular to the voltage. If voltage is here, magnetizing current is lags the voltage by 90 degree, exact 90 degrees. If it is a 90 degrees, what is cos 90? 0. Conversion rate is 0. But thing is, because of load, what will happen? There is one more component is entering the current, I2 dash. Right? Because of I2 dash, if you take care about magnetizing current and I2 dash, resultant current will come less than 90 degree. Anyway, see, this angle is more in case of induction motor because of magnetizing current. But in case of PMSM machine, technically, mathematically, if you verify the required magnetizing current under no load condition, ideal condition, it is almost 0. If magnetizing current requirement is 0, see, if you verify input current, it will come closely to I2 dash is coming closely to, see, if I mu is 0, I1 and I2 dash both are in phase. You got my point? Nothing but your input current will come closely to voltage. Nothing but energy conversion rate is more. The beauty of magnets is it will provide environment. It will provide good environment without need of magnetizing current. If you want to do any job in electrical engineering, it requires reactive power. But issue with reactive power is if you want to maintain sufficient reactive power, right? Issue is it requires magnetizing current. The drawback with magnetizing current is power factor will get poor. The issue with magnetizing current is it will reduce the energy conversion rate. But if you want to do work, it required reactive power. Both. See, by adopting permanent magnets on the rotor side, advantage is, right? See, it will create good environment. If you want to do anything, first requirement is environment must be good. If environment is good, we can able to do our job effectively. If environment is not good, right? See, lights are blinking. It is very difficult to writing the notes, right? You got my point? If lights are blinking continuously, it is very good, very bad to write the notes or to attend the classes or to understand the concept. See, whenever you want to do some work, initially you need to take care about what is the nature of, what is the strength of reactive power. That is what we are doing in armature voltage control method as well as V/F method in AC machine. In armature control method, see, we are providing good environment to the DC machines. Nothing but we are maintaining sufficient reactive power in the air gap. Right? See, the beauty of magnetic circuit is, right? If you take any dynamic machine, there is a air gap is there between stator to rotor. The nature of air gap is it will store the field energy. Almost 98% field energy is available in air gap only. Any electrical machine. If you take any electrical machine, field energy is so important. The drawback with electric circuit is we cannot transfer the electrons from one circuit to another circuit through air. But beauty of the magnetic circuit is we can transfer the energy from one circuit to another circuit through air gap. You got my point? So once you excite the stator, what will happen? Whatever electrical energy you are supplying, it will convert it in terms of field energy. Right? The ability of the air gap is it can store, it can hold the field energy. 86 to 88% field energy is available in air gap only. Now question is, what is the significance of field energy? That is what we have studied in energy conversion in all electrical machine. What is the significance of field energy? Anyone? Okay, fine. If field energy is vary with respect to rotor position, then only your machine torque become finite. Field energy must vary. No option. Whatever energy is available in air gap, that energy must vary with respect to rotor position, then only you will get twisting force. This is the logic. This is the logic behind the electrical machine. This is about This is the nature of torque generated by the all electrical machine. We don't have any option, we don't have any freedom, right? This is the standard mathematical expression applicable for all electrical machine. If you want to produce the torque, field energy must vary with respect to rotor position, right? So there are different types of torques we can able to produce using, see, one is called reaction torque machines, another one is reluctance torque machine. If self inductance is vary with respect to, if self inductance is vary, I am telling inductance will play key role in all electrical machines. We are thinking that inductance is a constant. Inductance is always regulating with respect to rotor position. Clear? If rotor position is changes, inductance is also changes. Right? Field energy or co-energy, see this one, if co-energy or field energy is vary with respect to position, then only you will get non-zero average torque. If torque is non-zero, then immediately you will get acceleration mode. Your drive will enter in acceleration mode. If you take any drive, commonly it will operate in three mode. One is accelerating mode, another one is steady state mode, last one is final one, deaccelerating mode. Right? Accelerating mode or deaccelerating mode or steady state, it is completely under your control. Torque, based on the torque levels, right? We can able to, by controlling this one, right? We can able to control. Next, one more important thing is by remembering this equation, omega m equal to omega s plus or minus omega r. This is the standard mathematical expression, right? Speed of the rotor expression. This equation is applicable for all electrical machine. By taking this equation, we can understand what is the logic behind DC machine, what is the logic behind induction motor, what is the logic behind synchronous machine. We will get. In case of DC machine, where omega s is the angular frequency of the stator, speed of the magnetizing pole, stator's magnetizing poles. Omega r is the, see, mathematically omega s equal to 2 pi fs, omega r equal to 2 pi fr, right? Now question is, in case of DC machine, what is the essential condition to get non-zero speed? If speed is finite, you can understand that inherently there is a torque production is there, right? This is important. This parameter is so important with respect to customer point of view. As an electrical scholar, you need to take care. As an electrical scholar, these two are under your control. Am I correct or not? These two are under your control. By regulating these two, we can able to control the speed based on the requirement. In DC machine, right, what we are doing intentionally, we are maintaining supply frequency Fs0. If Fs is 0, what is happening? If Fs is 0, stator frequency is 0, then what about omega s? 0. If omega is 0, what is omega m? Omega m and omega r both are same. What is omega r? Omega r is nothing but Fr. It is directly proportional to Fr. What is Fr? See, n equal to 120 f by p. This is the standard mathematical expression for speed. Can I ask one question here? Important question. It is related to electrical engineering only. All are in electrical. What is frequency? What is the definition? There is a standard definition is there for frequency. What is the definition for frequency? No. Whatever we are learning in class, standard definitions, we should not discuss here. We have to think in other way, beyond. See, frequency is nothing but relative motion. You got my point? Frequency is nothing but frequency they will decide based on the relative motion between the magnetizing flux and conductor. How frequency will decide? Based on the relative motion. Based on the relative motion between the physical conductor and magnetic circuit, they will decide the frequency. Why brushes? DC machine, why brushes always will operate with zero frequency? What is the reason? In case of DC machine, brushes are always operating with zero frequency. What is the reason? The relative motion between the brushes and magnetizing poles are 0. Both are with respect to each other 0. Relative motion is 0. That's why brushes are always operating at 0 hertz. You got my point? That's why with respect to brushes, current voltages after commutation action always 0 hertz. Clear? Understood? Now, see here, in case of DC machine, because of commutation action, right, we can able to maintain FR is exactly matching with NR. So because of this reason, if NR is finite, automatically omega m is also finite. If omega m is finite, customer feel happy. You got my point? So to get required speed in case of DC machine, intentionally, right, we are maintaining stator frequency 0. If stator frequency is 0, based on this operating, right, speed of the rotor, we can decide frequency of the rotor. Frequency of the rotor and speed of the rotor both are same. FR is directly proportional to NR, right? So NR and omega m both are same. Mechanical speed and electrical speed both are same in case of DC machine. You got my point? Right? Electrical frequency and mechanical speed both are same in DC machine. But come to induction motor. In case of induction motor, we cannot access rotor bar. Am I correct or not? Rotor frequency is not in your hand. It is simple induction principle. Based on the induction principle, what will happen? Your rotor frequency is FR. It is SFS. Right? So, right, stator frequency is also finite. That is omega s. Omega s minus omega r we are maintaining to get finite amount of the speed because of induction principle. Because of the slip, we are maintaining this condition so that we are getting speed. What is omega r? Omega r is nothing but angular frequency of the rotor current. Omega s is angular frequency of the stator currents. By taking this difference, you will get required speed based on the customer. This is what we are doing in the induction motor system. Now come to synchronous machine. In case of synchronous machine, what we are doing? Throughout the operation, to satisfy the customer, intentionally we are maintaining FR 0. If FR is 0, then what about omega m? Speed of the rotor is matching with omega s. That's why it is called synchronous machine. Speed of the rotor is always at any instant of the time it is matching with omega s. If you want to operate your system in synchronous mode, essential thing is your rotor frequency must be 0. If it is a 0, then omega m is matching with omega s. You got my point? So that's why in case of synchronous machines, rotor poles are excited with 0 hertz. If it is a 0 hertz, then only we can bring the omega m to omega s. This is this standard mathematical expression for all. This equation is applicable for all machines. So as an electrical scholar, if it depends on the universal expressions concept, we can easily understand. We can easily compare the behavior of the each system so that finally we can derive the conclusion. Based on the conclusion, we can easily identify the application. Our target is the application, right? As an engineer, we are not focusing on the application. Simply we are working independently. That is the issue with present research side. There are two things are there. One, let them that there are two students are there in the class. One student is doing project based on the customer need. One student, he will do excellent product, but it is not useful to the customer. Idea is very good, excellent. Product is also very good. But thing is, it is not suitable for application point of view. But a student, idea is simple, effective, right? It is not much innovation is there in that product, but thing is that product is effectively utilized to the customer. Definitely a student will success in the market. You got my point? So whenever you want to do some research or whenever you want to find something, first top priority is you need to get the need from the customer. Once you know the need from the customer, right, next we can easily summarize the problems, we can easily uh, uh, keep the problems in descending order, seriousness. First you have to give top priority for the serious issues, right? After that you can ignore the minimum, right? Based on the ranking we can decide the order of the problems, right? This is, see, next, this topic, this is our main focus on today's session, right? After that, what is time? 4 5 minutes, 2 minutes. After that I will give break. So see, if possible you can, there are some powerpoints are there, you can charge your batteries. We'll try to develop the model now. 4 to 4:10 to 5:15 we'll try to do exercise on the DC motor characteristics, extracting the DC motor characteristics through the mathematical model. After that, transformations also we'll try to focus, right? Power variant and magnitude invariant, these two concepts we'll try to understand, right? After that I will see, after session I will try to share a video lecture to everyone, induction motor model, right? You can try yourself. Why? Because see, first initially we'll try to apply FOC to induction motor, right? Later we'll apply FOC to PMSM machine. Directly if you go to the PMSM machine, it understanding very difficult. Slowly, step by step we'll go. Clear? Now see here, what is there is a common point is that if you observe these three diagrams, there is a one common point is there. What is the common point among these three waveform? See, even if you take this one, this is about natural system. Your natural system is always in AC. Your natural system input voltage is always AC. Why? Why we need to apply sinusoidal signal? There is a logic is there. Why we need to apply alternating signal across winding? Why we need to apply alternating signal across the stator terminal? Reason is your winding is in stationary. Naturally, all stator windings are stationary. You got my point? This is a very important point. Your coils are stationary, your winding is stationary. You need to apply alternating signal, right? But with respect to control point of view, what we are doing is, without losing any property, we are rotating winding, right? We are assume that winding is rotating, so that what will happen? Required voltages, required currents are converting into DC. Naturally, all windings are in stationary. Stator coils are stationary. But control point of view, what we are doing by applying these techniques, right? We are rotating the windings. Artificially, we are rotating, so that required voltages, required currents will converted into DC. If currents or voltages are in DC nature with respect to control point of view, your job become very simple. You need to concentrate only on magnitude control. If it is AC, you need to take care about magnitude as well as phase. You got my point? That's why these transformations are so important with respect to control point of view. See, practically, even if you take BLDC motor, SRM, PMSM machine, induction motor, right? All windings, right? Whatever windings we are exciting, all are stationary. Physically, there is no movement. Right? So that required shape of these signals, required shape of the electrically required shape is sinusoidal signal is required. Right? Whenever you apply this three-phase voltage across your motor terminal, what will happen if you take induction motor? This is the nature of torque generated by the machine. You got my point? This is about torque versus speed characteristics of the machine. Right? What is Clark transformation? What is Clark? Clark is nothing but three-phase to two-phase stationary. Right? Nothing but, see, still your winding is your in complex plane, still your windings are two-phase windings are stationary. Right? In case of three-phase, this is about your windings. right? In case of Clark transformation, what they are doing is they are taking, instead of 3-phase, they will take 2-phase system, right, with stationary coils. Your coils are stationary, still speed is 0. This is nothing but Clark transformation. In Park transformation, what they are doing, this winding they will rotate with particular speed. How much speed you will get clarity after completion of field orientation method. How much speed with how much angle with respect to particular angle, right? If you take care about the position of the winding, definitely we can change the characteristics of the machine with respect to control point of view, right? Now here, see, thing is whether your coil is, whether your reference person, now this is our reference person, whether, see, now reference person is sitting here. If person is speed is 0 or person speed is some finite or arbitrary speed, irrespective of the speed of the person, the behavior of the torque profile will not change. This is a very important point, right? You got my point? See, even if you take reference person, speed is 0 here, or person is rotating with omega equal to omega a, some arbitrary speed, with respect to this person, with respect to this person, or with respect to this person, with respect to 3-phase system, or 2-phase stationary person, or 2-phase rotating person, if you calculate torque generated by the machine, in all cases you will get same behavior. Same profile you will get. Property will not change. Information, you will not lose any information. But thing is, reference point speed is, reference person speed is regulating, right? See, issue is with Clark transformation, advantage is number of variables are coming down. But still problem is, still your variables are in alternating nature. This is the issue. That's why later they have proposed Park transformation. By adopting the Park transformation, 2-phase variables we can convert it into DC. If you want to change the voltage behavior from AC to DC, right, essential thing is you have to assume that your winding is rotating at synchronous speed. If winding is rotating with same speed of the magnetizing poles, then signals are required, signals, voltages or currents are required, current or required voltages are in DC nature. You got my point? So this is so important. Even person is rotating or stationary in 2-phase or 3-phase with more number of variables. See, whatever behavior you are getting with 7 state variables, with less number of variables also you will get same behavior, right? Behavior will not change. Only complex, see, number of variables involved in the system will decrease. If you want to improve the profile, what it required? Essentially, you need to take proper power electronic model. This is a very important, right? By selecting the proper power electronic model with transformation technique, and right, see, so these are all the methods. Whenever you want to improve the steady state profile as well as dynamic response, you have to go through these 4 points. No option. We don't have any freedom. Whether it is a PMSM machine or induction machine or, right, any special machine, we don't have any freedom. We have to go through these 4 points. First one is, what is the first point? First, we need to understand the behavior of the actual system through mathematics. This is what we are doing now, initially. So what is the outcome of our session? My target is selecting vector control technique to eliminate the nonlinear. This part, at the end of this course, you will get clarity. So in today's session, my job is, I am trying to explain the how to understand the behavior of the various electrical machine, how to apply transformation technique to reduce the complexity. These 2 topics I am focusing in today's session, right? In next session, I will try to, by using hierarchy, by taking care about the control hierarchy, right, with proper power electronic model, how we can improve the dynamics, we will try to discuss in detail in the next session, right? After break, we will try to focus on, right, see how to develop the mathematical model of the DC machine, right? Then after that, you decide. If you are very familiar to the DC machine, directly I will go to transformation. Mathematical model of DC machine or mathematical model of transformation, which one will start? You decide, participants. You know mathematical model of DC machine, right? How many know? Can you raise your hand if you know the, how many participants know the mathematical model of DC machine? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then what we'll do? Tell me. We'll develop 10. I will not spend more time. See, my problem is my lectures are going very slow. My teaching method is very, very slow. I don't know how many participants are following or not. Real. Say any questions before break. If you have any questions, you can ask. Everyone is following. Fine, clear, fine. Okay. Any questions are there? You can ask. Then see what I will do is first I will focus on the transformation. Why? Because it is no more related to the mathematical model of the system. It is completely, concept is different. I will write equations, same equations you have to develop in your simulation file. You will get result, right, for magnitude variant and power invariant condition. Particularly magnitude invariant condition, power invariant condition is so important for power quality applications. Whenever you want grid connected inverters, whenever you want to control real power or reactive power effectively, right? See, magnitude invariant condition is so important. So sorry, power invariant. Magnitude invariant condition for drives application, it is sufficient. By applying magnitude invariant condition, we can able to extract the torque characteristics without losing any property, right? Okay. Anyone want to ask? I'm telling windings are stationary. If coil is stationary, see, one very say, if coil is stationary, why we need to apply sinusoidal? Relative motion. Okay. What is the benefit you will get? Okay, if you maintain relative motion, what you will get? See, if you want convert the energy, what is the significant parameter in the circuit? Back EMF. Back EMF is so important for energy conversion. If back EMF is less, what is the issue? Machine will take more current, losses are more. See, based on the back EMF and current, we can decide how much energy is developed in the rotor. We can decide. Power developed in the rotor is nothing but back EMF into current only. But issue is, if back EMF is less, current is more, heating effect is more. If back EMF is more, current is less, right? Advantage is we can operate more period. If you want, that's why as an electrical scholar, you need to take care about what is the nature of back EMF. Based on the back EMF nature, we can decide the reliability of the system. That's why BLDC motor morning, see, one participant, I think they ask questions. What is the difference? Why BLDC motors are not adopting in transportation system? BLDC motors generally they are adopting for low power drives. Reason is current is not sinusoidal. Heating effect is more. Whenever you want to use BLDC motor effectively, you have to reduce the power levels. By reducing the power levels, right, without heating effect, we can operate more period. Main advantage of the BLDC motor is design is simple. Concentric winding is very simple. Coil replacement is also very simple. Control is also very simple. But PMSM machine, winding design, distribution factor, pitch factor is very difficult. Designing the distribution winding is more complicated than the concentric winding, right? But advantage is your back EMF becomes sinusoidal, current is sinusoidal. If current is sinusoidal, heating effect is less. These are all the advantages, right? Next important thing is, if coil is stationary, you don't have any option, you need to apply sinusoidal. If coil is rotating, then you need to apply DC. If it is a DC, even coil is rotating, with respect to rotating coil, your signal is looking like sinusoidal. You got my point? Your back EMF, energy conversion is taking place, right? So after the break, we'll try to concentrate on how to develop the transformation technique initially, right? After that, after completion of this task, then we'll try to focus on mathematical model of decimation, right? Then assignment one is induction motor model you have to develop by Wednesday. Is fine Wednesday or Thursday? How many students already they develop induction motor model? Can you raise your hand? Already you have developed, right? Sorry, 5 phase. Even if it is a 5 phase or 3 phase, we need to develop model in 2 phase on. How many students can you raise? Once again, 1, 2, 3, 4, 4. You have developed induction motor model. Okay, only 4. Then assignment I will give. Other students can help. My scholars also they will help. I will give my scholars phone number, mail ID. You can contact through mail or phone. They will help. I will also help, right? Anyway, I will forward equations. Only your job is you need to substitute the equation in MATLAB. You will get behavior of the system, right? It is not a big deal, right? First try to get the mathematical model of induction motor. Before coming to the next session, I will try to forward PMSM machine model assignment. I will explain the concept. Assignment is model you have to develop in your hostel. Why? Because see, please try to understand. Uh, okay, now break time again. It will go up to 5:30. I will stop here. Huh? Okay.